Here I'm going to solve the first example based on the capacitors are in series and parallel. Okay, here we have, 6 capacitors connected in series and parallel combination. The question he's asking about, find the voltage drop across each capacitor and charge on the each capacitor and the total capacitance. Okay, as I mentioned, always, as I mentioned in the previous videos, when you're finding total resistance, here what we're going to do, we always start solving the example from the capacitor which is far away from the open terminals. Okay, so here he clearly mentioned you have a 100-volt source connected here. Okay, so now we're going to start with 6 microfarad capacitor which is far away. I usually label them C1, C2, C3, C4, C5, C6. Okay, I always start solving the capacitors from C6. Now if I look at C6, is it series with C5 or series with something or parallel with something? How do you know? Remember, if you can walk through the two capacitors without dividing, so start walking from here. Okay, now see, I can walk through those two capacitors without dividing at any point. Then I can say those two capacitors are in series. So I can say C5 series with C6. Okay, so I'm going to label that as C7 equal to C5 times C6 over C5 plus C6. This is where you're going to have a big confusion why I'm writing the parallel formula for series. Okay, remember it is opposite to the resistors. So this formula we use it for resistors if they're in parallel, but when it comes to capacitors it is going to be opposite. So if capacitors are in series, then we will use this formula. So 3 times 6 over 3 plus 6, I'm not using micro, but you will end up with micro at the end, so which is going to be 2 microfarad. Now the 2 microfarad, it's a good idea to draw the diagram. So I'm going to draw the diagram again. I have C1, C2, C3, C4, and then C7. All of it is connected to a source. Okay, now if we look at the diagram, I can clearly see C4 is parallel with C7. I'm going to label that as C8. So C8 equal to C4 plus C7. I have 4 plus 2, which is 6 microfarad. Now I can clearly see, C8, once I replace this C4 and C7, I'll end up with C8. C8 is going to be, so if I redraw the diagram again, so it's going to be something like this. Make sure you have both plates in the same size, okay, to avoid confusion with the battery. So this is C3 and C8. This is how the circuit is going to look like. By the way, the given circuit, it's look like a ladder, so we call this as a ladder circuit. Okay, now so if you look at C3 and C8, C3 series with C8, so I'm going to label that as C9. C9 equal to C3 times C8 over C3 plus C8. So I'll end up with 6 times 6 over 6 plus 6. If you remember from the resistors, okay, if two equal values are in parallel with the resistors, it's going to be that resistance divided by number of resistors. Same thing here, if two equal value of capacitors are in series, then the resultant resistance or resultant capacitance equal to 6 divided by 2, which is 3 microfarad in this case. Now I have C9, so I can replace this C3 with C9. So if I replace that with C9, that is C9 and C2. You can clearly see C2 and C9, they are in parallel. So C2 parallel with C9, I'm going to label that as C10, which is C2 plus C9. What we have C2? C2 equal to, this is 1 microfarad. Now I end up with 3 microfarad here, so the total equal to 4 microfarad. Okay, now C total I can clearly see is C1 and C10. Now if we look at here, that's a C total. C total equal to C1 times C10 divided by C1 plus C10. Okay, what is C1? C1 is 12 microfarad. So this is 12 micro, this is 4 micro. So I end up with 12 times 4 divided by 12 plus 4. I have the total of 3 microfarad capacitance. This is the C total. Okay, once I know the C total, most probably this is what I'm going to ask in the exams. Find the total capacitance value based on the series connection, parallel connection. Okay, I'm going to stop this video here. The rest of it I'm going to explain it in another video. Thank you.